Hello friends, in this video we will be looking at how to find the greatest terms in binomial expansion. Suppose we are given an expansion x plus a to the power n. So this can be written as nc0 x to the power n plus nc1 x to the power n minus 1a, and this goes up to ncn a to the power n. I'm required to find the greatest term in this binomial expansion, and by greatest term I mean the numerically greatest term. I am not interested in the positive or negative signs that are associated with the terms. Okay, so we will be keeping this thing in mind. Let us suppose that tr plus 1th term is the greatest term. Okay, if tr plus 1th term is the greatest term, then obviously tr plus 1th term is going to be greater than or equal to tr. Okay, also we can say tr plus 1 upon tr is going to be greater than or equal to 1. Now what is tr plus 1? Tr plus 1 is ncr, okay, x to the power n minus r a to the power r, and rth term is ncr minus 1 x to the power n minus r plus 1 a to the power r minus 1. Fine. Now using this relation I can write ncr x to the power n minus r a to the power r upon ncr minus 1 x to the power n minus r plus 1 a to the power r minus 1 is greater than or equal to 1. Solving this, we already know ncr upon ncr minus 1 can be written as n minus r plus 1 upon r. Okay, if you have a problem in this one, how I directly wrote this, you can solve it. Pause the video and solve it on your own. Very easy, you will get it. Okay, now substituting this value in the above relation, I will get n minus r plus 1 upon r multiplied by what we have. We will have one a left in the numerator and one x left in the denominator, because the difference of indexes is only 1. Okay, so this is a by x is greater than or equal to 1. Initially I said that I am only interested in the numerical values. I will not be considering the positive or negative signs. To avoid that situation, I am putting a mod sign over a by x. Fine. Now let us solve this to find the value of r. Okay, I can write n minus r plus 1 into mod a is greater than or equal to r mod x. Rearranging it, I can write r mod x plus mod a is less than or equal to n plus 1 into mod a. Fine. Or r is less than or equal to n plus 1 mod a upon mod x plus mod a. Again I can write r is less than or equal to n plus 1 upon 1 plus mod x by a. Fine. So this is the relation by which we will be finding the value of r. Now suppose n plus 1 upon 1 plus mod x by a is equal to k. Okay, so now I can write r is less than or equal to k. Now this k can be an integer and a non-integer. Okay, only these two are the possibilities. So I can express k as n plus f, where n is natural number, and f is fractional part. Fine, this is the fractional part and it lies between 0 and 1. Fine. Now two cases arise. First, k is integer. Okay, if k is integer, we will have two greatest terms. Fine, we will have two greatest terms. R will become less than or equal to k, means r becomes less than or equal to n. the two greatest terms will be tr plus 1 and tr at r is equal to n. Fine. These two will be the greatest terms. The next case is k is not an integer. K is not an integer. In such a case, I will write k is less r is less than equal to k, or r is less than equal to n plus f. In this case, only one greatest term, fine, only one greatest term will occur, and that will be tr plus 1 at r is equal to n. Fine. So what we have done is we have assumed that tr plus 1th term is the greatest term, and then we have exploited this relation to find the value of r, or actually some boundations on r. After we have found the value of r, I have to analyze the situation whether the number written on this right side, which we have called as k, is an integer or non-integer. Okay, if it is integer, I will get two greatest terms, two equivalent greatest terms, and those will be tr plus 1 and tr at r is equals to n. Fine. And how to find n? This is the relation to find n. Okay, and if n is not an integer, then I will have only one greatest term, and that will be tr plus 1 at r is equal to n. Fine. Okay, so now let us take an example to make our understanding more clear and firm. Okay, so suppose I am asked to find the greatest term. Okay, greatest term in the expansion of 2 plus 3x to the power 9 at x is equal to 3 by 2. Okay, so again let us suppose tr plus 1th term is greatest. Fine, this is our greatest term. So tr plus 1 upon tr has to be greater than equal to 1. Fine. And this is n minus r plus 1 upon r. I am writing it directly. You can solve it if you want to. Okay, and what was that? Let's find it. It was, let's see what it was, a upon x. Okay, a upon x. So what is our a here? Our a is this, and this is x. Fine, this is x plus a. This is written x plus a. So I will write here 3x upon 2. I am not introducing the mod sign because 3x and 2 both are positive, so no need to introduce the mod sign here. This is greater than equal to 1. Fine. Okay, now n is equal to 9, x is equal to 3 by 2 in this question. Putting the values, we get 9 minus r plus 1 upon r multiplied by 3 by 2 into x is also 3 by 2 greater than equal to 1. This is 10 minus r upon r. This is 9 by 4 is greater than equal to 1. Now 90 minus 9r is greater than equal to 4r, or I can say 13r is less than equal to 90. R is less than equal to 90 upon 13. When you will calculate it, you will get this is 6 whole 12 by 13. Okay, so obviously this is not an integer. Okay, this is not an integer. If this is not an integer, I will get only one greatest term. Fine, only one greatest term at r is equal to 6. Okay, what I initially assumed, tr plus 1 is greatest. Fine, at r is equal to 6. So what is the greatest term? t6 plus 1, which is equal to 9c6, 2 to the power 9 minus 6, and 3x to the power 6. at x is equal to 3 by 2. This becomes 9c3 2 cube 3 into 3 by 2 to the power 6, and I am writing it directly. I am writing the answer directly. You can solve it on your own. This is 7 into 3 to the power 13 upon 2. Okay, so this is the required answer. Okay, I hope now this topic is clear to all of you. Thank you very much.